We live in an extraordinary time, when our gaze into the cosmos is returning something unexpected. For centuries, our solar system seemed a self-contained island, its celestial bodies orbiting the sun in a predictable dance. Our telescopes have begun to detect visitors from beyond. 3 interstellar travelers have been observed. They present a profound question. Are these objects unusual natural phenomena or something else entirely? To understand the puzzle, we first introduce our 3 protagonists. The first, One-Eye Oumuamua, detected in October 2017, was immediately strange. Small, highly elongated or pancake-like, and accelerating without a visible cometary tail. The second, Two-Eye Borisov, behaved as a textbook comet, broadly consistent with our models. Then came C 2019 Y4 Atlas, later redesignated 3-Eye Atlas, far more enigmatic. In early 2020, it fragmented into multiple pieces, each a clue to the original object. To analyze these objects, we organize anomalies into a hierarchy. At the base is motion. Any deviation from gravity is significant. Oumuamua's gentle acceleration and Atlas fragment dynamics challenge simple models. Chemistry. Borisov rich in expected molecules. Oumuamua chemically silent. Structure. Oumuamua extreme. Borisov stable. Atlas defined by fragility. This pattern points to specific weaknesses in our models, with Oumuamua and Atlas as outliers. The scientific process tests 2 broad systems, natural and artificial. The natural system explains observations via known astrophysical processes. The artificial system allows the possibility of design and engineering. To date, no radio signals, no unnatural metallic compositions, no maneuvering. As Carl Sagan said, extraordinary claims require extraordinary evidence. Both systems must explain all facts with fewest assumptions. This is not about belief, it is about rigorous comparison and following the evidence. We must introduce the concept of origin. Asking origin moves us beyond properties to the process that made them. Within the natural system, origin is a chain of astrophysical processes. In contrast, artificial origin implies intelligence, design, and purpose. Oumuamua could maximize surface area as a sail. Non-gravitational acceleration may be passive propulsion. Origin reframes our search. Specific strangeness can discriminate formation from fabrication. The first formal hypothesis is that all 3 are purely natural, adhering to Occam's razor. For 2-Eye Borisov, this works perfectly, validating predictions. For Oumuamua, several exotic but plausible scenarios have been proposed. For 3-Eye Atlas, extreme fragility and uneven outgassing could drive the breakup and fragment velocities. But precise fragmentation models are still under development. A single, coherent natural model for all Oumuamua and Atlas oddities has yet to emerge. The second hypothesis posits artificial origin, potentially a light sail for Oumuamua. Flat, high aspect ratio, accelerating without outgassing. Tumbling could indicate a defunct artifact. For Atlas, fragmentation could reflect a complex device shedding parts. Limitations: no transmissions, no non-ballistic maneuvers, no manufactured alloys detected. Arguing it's artificial because we can't explain it is argument from ignorance. Acceptance requires evidence impossible to produce naturally until then, intriguing but unproven. Oumuamua was fleeting. Borisov confirmed expectations. Atlas unfolded as a live-action experiment in celestial mechanics. Its breakup process spanned weeks, allowing multi-epoch measurements. Standard drivers: tidal stress, gas jets, rotation, thermal stress, yet Atlas broke far from the sun. Key tests reproduced the number, sizes, and especially the velocities of fragments. A mismatch implies incomplete physics. A match strengthens the natural framework. We replace a binary choice with comparative analysis across anomalies. Assign weights to motion, chemistry, and structure based on data quality and significance. Score each hypothesis on explanatory scope, parsimony, and predictive power. Borisov, natural model robust across all tiers. Oumuamua, high anomaly density. Atlas, decisive structural and dynamical test. Comparative analysis clarifies priorities without overcommitting to premature conclusions. A functional perspective asks, what does it do, not just what it is? 4. Oumuamua. Sustained non-gravitational acceleration, no detectable outgassing, complex tumble. For Atlas, convert breakup into measurable functions. Fragment energy, dispersion patterns, jet asymmetries. Natural functions imply sublimation thrusts and rotational instabilities. Artificial functions imply radiation pressure sails or designed separation events. Map observed behaviors to functional predictions to guide targeted observations. A methodological framework prioritizes precise astrometry, repeat spectroscopy, multi-epoch photometry, coordinate global telescopes for continuous monitoring during critical phases, use closed-loop modeling, generate predictions, compare to data, update parameters transparently, pre-register analyses, share data and code to reduce bias and overfitting. Define falsifiable criteria for artificial hypotheses, e.g., coordinated maneuvers, non-natural spectra. Demand peer review, replication, and expanded surveys to generalize conclusions. The arrival of these objects marks a new chapter in astronomy. Borisov anchors the natural picture. Oumuamua and Atlas test its limits. Using a hierarchy, dual systems, and an origin lens brings clarity without overreach. Future surveys will expand the sample and sharpen our tests. The goal is clarity and intellectual honesty, acknowledging strengths and weaknesses of each hypothesis. Our models are incomplete, but our methods are strong. One observation at a time, the universe will answer.